starting with number 41 first today. The equation 24x squared plus 2x equals 15 has two solutions. What is the greater of the two solutions? And so there is an answer here, or there might be two that fit this equation, but we're looking for the one that is the greatest. And if we pay attention to the way these are written, we can see that the bigger ones is starting smaller, and it looks like it's, well, actually, I apologize, it's not in order this time. So we have 3/4, then 4/3 with it, which is bigger, and then they drop back down to being less than 1. So what we want to do is try to start with the biggest options possible and plug them in, and if it works, then we've gotten our answer. If not, we'll go down to the next biggest until we can find the solution. So 4/3 is the largest answer choice on here, and then we'll go to 7/6. We'll put 4/3 in everywhere there's an x, and if it works out to equal 15, then we know we have a solution. So in my calculator, I'm going to do 24 and then 4/3 squared plus 2 times 4/3. And so that gives me 136/3, which is clearly not 15. So B is not the answer. All right, I'm going to go to the next highest number, and that's going to be answer choice D, which is 7/6. So 24, 7/6 squared plus 2 times 7/6. And that gives me 35. So that doesn't work either. Okay, let's try 5/6. 24, 5/6 squared plus 2 times 5/6. And again, that's not the answer. It doesn't give me the 15 that I need. All right, so we'll keep going. Let's try the 11/15. 24, 11/15 squared plus 2 times 11/15. And that still doesn't give me the answer. So I'm left with A as the answer for this, but just to confirm, 24 3/4 squared plus 2 times 3/4. And that does come out to be the 15 that we need. So this is a solution. It is A. Number 42. It says, which of the following expressions is equal to sine 60 cosine 30 plus cosine 60 sine 30? Now, I know there's one of those sum or addition rules that if you remember the formula, then you can just say, oh, this is such and such formula. Like it's either a double angle formula or half formula, like half angle, which we see in K, or it's a sum or difference formula like we see in FGH or J. Now, if you don't remember, like I don't remember off the top of my head, then you can use your calculator to determine. Okay, so one thing is the cosine of 60 minus 30 is the same thing as cosine of 30. This is 90. This is sine of 30 and sine of 90. And this is sine of 45. Okay, and we can get these values in our calculator. All right, so I am going to type this entire expression in up here in my calculator first and get the value and then narrow down which ones I want to check against the answer choice. So do make sure your calculator is in degree mode. That's very important. I got sine of 60 times cosine 30 plus cosine 60 times sine 30. And the answer is 1. Okay, so I'm looking for which one of these values also turns out to be 1. Okay, so we have sine of 90 is what I'm pretty sure is just my memory, but we can type that in. Sine of 90 degrees is 1. So that was the answer. It is J. This is an addition formula with sine. 43. It says, what is the area in square units of a circle that has a circumference of 12 pi units? So you'll see here we have to know the formulas for the area of a circle and the circumference. It is not something that is provided to us on this test. So the area of a circle is pi r squared, and the circumference is 2 pi r, or you can think of it as pi times the diameter. Either way. So right now we have 12 pi. We can determine, that's the circumference. We can determine from that information that the radius is 6. Okay, so we know r is 6 because if 12r is the circumference, we can divide that diameter of 12 by 2 and we get the radius is 6. Now we take that 6 into this area. So 6 squared is 36. 36 pi would be the area for this problem. All right. So I hope that made some problems that might have seemed like they were rather difficult a little bit simpler for you with us breaking it down that way. Number 44, a barrel contains 25 liters of a solvent mixture that is 40% solvent and 60% water. Okay, so that's one scenario there. Lee will add pure solvent to the barrel without removing any of the mixture currently in the barrel so that the new mixture will contain 50% solvent and 50% water. Then the question is asking, how many liters of pure solvent should Lee add to create this new mixture? Now, let's think about this. Originally, the barrel is of 25 liters and 40% is solvent, 60% is water. So we can actually determine those real numbers. We don't have to use a percentage. So 40% of 25, that's just 0.4 times 25. That means that 10 liters are solvent. 10 of the liters, so that's a 10, and then that's supposed to be an S, okay? Plus the remaining portion, of course, 25 minus 10 is going to be 15. So that's what we start off with. And we've got 25 liters, 10, that's a 5. You have 10 that are solvent and 15 that is water. Now, Lee is not going to remove anything from this mixture. He's not going to remove anything, but he needs to add some liters. Okay, he's going to add some more mixture until it's 50-50. Okay, the question is how many liters of pure solvent, just solvent only, should Lee add to create this new mixture? And then the answer choices are here, so we really can be clever and use the information in the answer choices to plug in and see if they will work. Okay, so if we add 2.5 liters of solvent, then we'll end up with 12.5 in solvent, okay, and still just 15 in water, right? And then this total comes up 2.5. either way it goes, I don't really have to calculate the total. I mean, I know it's going to be 27.5, but either way, this is not 50-50. So it's not F. Okay. Well, what if we tried 5 liters of solvent in here? So if I add 5 in, that'll be 15 for solvent. Oops. 15 for water, which looks good, but then we have to double check here. 5 plus 25, yes, that is 30 liters. So 30 liters, 15 would be solvent, 15 would be water, and that's 50-50. So this answer is G. And so that's how we would go about solving it from a problem-solving standpoint, not necessarily from procedures that you were taught. We are just trying to solve these problems as cleverly and as quickly as we can. Let's